Physical database design is the major domain of the database systems. In the database systems, there are two domains. The one is called physical design, the other one is called logical design. Logical design mainly used for the conceptual designing and conceptual implementation regarding the schema, whereas the physical database design is mostly related with the tuning purposes and the storage at the operating system level. We discussed this physical design earlier during these database development modules, but we will discuss in detail in today's module about the database administration. So we will cover in this physical database design the definition and concepts, criteria for physical design, analysis, database queries and transactions, time constraints of queries and their transactions, physical database design decisions, and tuning purposes of the physical design, and last we will discuss analyzing the queries again with the transactions. So basically, by definition, physical database design is the process of choosing a specific storage structure and access paths for the database files to achieve good performance for the various database applications. It means that we will normally consider physical database design on the basis of storage purposes. Normally we consider this one, how we can store the files, where exactly we should store the files, and segregation of the files as well, and data normally stored in those files at particular locations. Access path means that logically how data come out from those files and shows in the form of tables, and there are few layers come up with the access path. Like for example, data comes in the block size, blockways. From the block it goes to the extents. Extent, collection of extents means it's a table space or subspaces, and then at the schema level we will get normal a logical kind of display in the form of tables. So this is what we called access path. So access path, storage structure, and location of files and their sizes is basically a basic definition of physical database design. Similarly, each DBMS software offers a variety of options of file organization and access path. Like for example, in Oracle, it is giving you extend, segments, and table spaces. In Microsoft SQL Server DBMS, they are normally giving in the form of schemas and sub databases, and those are the basically access path from the point of view of a Microsoft product. Each DBMS includes various types of indexing, clustering of related records on disk, link related records via the pointers, and various types of hashing and partitions. For example, as I mentioned you that table spaces are being used in the Oracle and sub databases are being used in the Microsoft SQL Server. So what is the criteria? Why we do this one? It's basically idea is that how we fastly access the data, how we can manage, manipulate the records quickly in a very short time. So it goes to the tuning purposes. So tuning is normally managed so that we should refine our database and data access will be fast. So elapsed time between submitting database transactions for execution and receiving response. So response time is influenced by factors not under control of DBMS. Factors are communication, scheduling, and operating system. So basically any database which normally come up in practice, it is shown that Unix and Linux operating systems giving you a fast access as compared to Windows operating system. So now this what happened because operating system factors are also very important as compared to the access path or other storage structure issues. Space utilization is very important, that how much space is given to buffers, how much space is given to redo log files, and what exactly space goes to data files and their locations in the single machines, multiple copies. So the various other issues related to space utilization are normally managed in the physical design. Transaction throughput is very important. Every number of transaction processed per minute normally discussed many times. We have discussed from the point of ATM transactions, like you using your ATM card and how fastly it is connecting with the particular bank, and the bank is giving you some kind of options of with the withdraw cash value coming from, balance amount, and how fast you get those amounts. So that's the basic idea about the transactions. The files analysis of database design in terms of queries and transaction means files that will be accessed by the queries where the selection condition, equality, inequality, ranges of the clauses within the SQL, how those should be managed, attributes whose values will be retrieved by the query, and attributes on which any selection conditions. So that basically idea is that the size of the column, the validity of the column, frequency of the columns are very important within the table, and how columns are linked with each other. So joining, sizing, and similarly equality and ranges values are very important from the point of view of database queries. So as I mentioned you, the files that are modified means that how frequently we change the data. We change the data in tables, and behind the scene the files are updated. The attributes on which selection conditions for delete and update are very important as well. Time constraints of queries and transactions. Some queries and transactions may stringent performance constraints. For example, transaction may have constraint that it should terminate within 5 seconds on 95% of the occasion when it invoked, and then it would never take more than 20 seconds. So these are the comparisons that how much transactions are managing in one particular time, and which table and which column is accessing mostly as compared to other columns. So we normally manage in the form of percentage. The type of operations are very important from the point of view of physical database design, insert, delete, and update, because these affects the data files. So very expensive operations are insert, delete, and update, where we normally manage commit and rollback commands. So in physical design decision point of view, that we manage the indexing so that primary keys and other indexes run fastly, and we allocate separate files for them, and similarly the file size are also important for them as well. We need to decide whether particular columns need to be indexed or not. Multiple columns need to be indexed in the form of composite way. So those are the basic decisions we normally consider from the performance point of view. Whether to set up clustered indexing means multiple columns like 2 columns or 3 columns, hash index over tree index, that's basic idea. Whether to use dynamic hashing or for files, apply denormalization as well, separate logical related attributes in tables to minimize the redundancy. So these are the basic features normally when we decide the database design. Size of individual tables are very important. Number of distinct values in columns, time query submissions and its execution is very important. Partitions, index, buffer pool, temporary storages, input, output, and performance statistics like total read and write activities are very important from the point of view of physical database design. So physical database design tuning point of view, locking and logging is very important. Many times too many transactions are accessing and same place, same record or same column. So sometimes locking created, and those locking will be managed and will be adjust with from the point of view of throughput rates and log records activity. Index statistic means that number of levels in index, number of non-contiguous leaf pages. So those are very important, that how we manage the indexing from the point of view of tuning. Again, analyzing database queries and transaction means file that will be accessed by the queries, where conditions, and attributes and which join conditions. So these three basic requirements, normally these are the targeted points DBA normally considered. So where class, join, and attributes which are mostly accesses. So those normally help us to push us towards the tuning purposes as well. Similarly, attributes values will retrieved by the queries. Files that will be updated, insert, delete, and update are very important as well from the point of view of expensive operations. And for those one, we need to figure out that how we can manage physical files corresponding to these three operations. The attributes whose values will be changed by an update operations. So attributes is another key. So attribute, where condition, joins, and range operations are very important, and those are normally slow down the database access and for them we need to manage how we can organize our physical design. So physical design means that we are studying right now table spaces, extent, and other options as well, logical point of view, but those logical map with the physical design, and all the DBA portion and all the DBA discipline is basically comes up under the physical design.